Oxford is also where I learned a lot. So this is the first time where I used concepts such as artificial intelligence and machine learning. So are these terms familiar to you guys? What do you think of when you think of artificial intelligence? Anything springs to mind? Robots, I heard robots. Yeah, that's perfectly right, yeah. So artificial intelligence is this broad concept where machines, such as robots, do things that we consider intelligent. And at Oxford, I used a specific application of artificial intelligence called machine learning. Now, machine learning is where you can actually teach a machine to learn over time so that ultimately it can make decisions or predictions that are useful for us. Now, that might sound like a lot of mumbo jumbo, but essentially very similar to human learning. We are born as a baby, we don't know anything, we go to school, we train, we practice, and we become good at things. That's human learning. So let's take an example. Let's say I'm rubbish at cricket. It's true. So if we get the best bowler from Springdales school to go in the field and bowl a few balls, how many do you think I'd be able to hit? I'll tell you, 0. Won't be able to hit anything. But let's say we keep on practicing. Every day they bowl 100 balls, I try and bat. And we do this for 1 month. What will happen? After 1 month, I won't become way much better, but I'll become a little bit better. And let's break that down. How do I become a little better? Well, we can break it down. So I essentially got a lot of data, which in this case was all the cricket balls that were being thrown at me. Over the course of 1 month, I was able to analyze that. So hopefully, very quickly, I figure out whether they're a fast bowler or a spin bowler. I hope that happens quick enough. I can figure out what sort of speeds they're bowling, where the ball is bouncing, where it's turning, and so on. And over time, I can then make a prediction, so that when the ball comes and it bounces, I can make a prediction as to where the ball might go, and then make a decision as to what cricket shot I should hit. So essentially, our brain has done this, is looked at the data, analyzed it, and made a prediction. We don't even know our brain is doing this, but that's what our brain is doing. So machine learning works in a very similar process. So for example, it's used in YouTube. So I watch a lot of YouTube videos. So you know when you watch YouTube videos, you have this sidebar on the right which gives you recommended videos, right? Now, more often than not, those recommended videos are really relevant and they're really interesting, and I always click on it, and then I click on it, and then there's another one, and I click on that, and then there's another one, and I click on that, and then 5 hours later, I'm still clicking. But how does YouTube know which videos to recommend? How does it know which videos you like? It's based on machine learning. So it looks at a lot of data, which is your YouTube history. It looks at your YouTube history. It also looks at everyone else's YouTube history. So look at my history and says, aha, Rajbir, you like videos of animals doing funny things. And the last video you saw was this one of a cat sneezing. So it'll then look at everyone else in the world who also like cat videos, and it'll say, okay, from these people who also like cat videos, a lot of them like this video of a cat dancing. And so YouTube then makes a prediction based on that analysis that Rajbir, you also will like that video of a cat dancing, and sure enough, I did. So this is basically how machine learning works in YouTube. It works, you use it in Facebook, and Siri, and Amazon, and Google search. It's used all over. And at Oxford, I used machine learning in medicine. I used it to predict the risk of a person getting a disease. So this also worked on very similar principles. So I not only worked at the university, I also worked at the hospital. And so I was able to work with patients. And so for patients who gave us permission, we were able to use their medical records, right? So our data in this case was patient records. This could be doctor's checkups, this could be blood tests, this could be images such as x-rays, all of these records. We collected these records for thousands of patients, and we tracked these patients over a long period of time. I mean, some of these studies have been going on for 10 or 20 years. We tracked them for a long period of time to see which patients do they get what diseases. You know, do they get heart disease, do they get bone disease, do they get liver disease, and so on. And once we collect all this data, we can then analyze this. So we use statistical modeling. These are basically mathematical algorithms that can extract relevant information from all this data. And this is usually run on computers, and hence that's where the machine learning comes in. And once we analyze this, we can then make predictions. Now what's the prediction? If a new patient comes into the hospital and gives us access to their medical records, we can then make a very accurate prediction of when and whether and when they're going to get a heart attack, for instance. Now, these machine learning algorithms are really complex. They're based on advanced mathematics, and that's really where my background came in. But I can tell you they're based on very simple principles. So let's say we have patient A who's 70 years old, smokes every day, doesn't exercise, eats unhealthy, and we have patient B who's 30 years old, swims every day, eats very healthy. Who do you think has a higher risk of getting a heart attack? The 70-year-old smoker or the 30-year-old swimmer? All of you got that. Why? Because human learning. Because as a kid, you've always been told, okay, if you're old, you might get ill. If you better eat well because it's healthy, you better exercise, don't smoke, the things we've been told. And because of human learning, now in this situation, it was very easy to predict who is going to get a heart attack. With machine learning, you can deal with more complex scenarios. You can find even more factors associated with a heart attack, for instance. And you can make a very accurate prediction of when a person might get a heart attack. Now, why is this important? Well, because instead of waiting, let's say 10 years for that person to get a heart attack and then trying to cure it, it's better off to say, look, man, if you don't start eating these medicines or change your lifestyle, you will get a heart attack. So let's prevent it, right? So that's where you could use machine learning in medicine. Essentially, this was what I was doing in Oxford. And soon after that, I got into a PhD at Cambridge.